And my first question, and this is inspired by Jean's work, but it could be answered by any of you. How could advances in robotics and artificial intelligence enable more precise, safer, and more effective brain surgery to be performed?
In several ways, I guess, both at the front end. We need cells. We're doing an in-depth analysis of the fetal tissue that we're trying to reverse engineer. So that's a lot of omics data, both proteomics and glycomics and transcriptomics. So we're kind of slow in doing that. I'm sure that can be accelerated with smarter algorithms, if not AI. Also, the actual manipulation of the cells. So there's, as I mentioned, a lot of different precursor cell types. We do all that by hand right now. If that could be automated with tissue culture robots that can recognize the cells and do the work for us, that would accelerate things. And then also, at the implementation, you alluded to the surgical robots. Presumably, we can make robots that can see microscopically much better than we can, and do finer manipulations that we can to avoid blood vessels as much as possible. That kind of thing, could probably be designed. I don't know.
Any other thoughts, Nuno?
Yeah, we can add. Is the sound going through?
Yes.
Yeah, we can add that with future nanotech. What Jean just said. We might indeed go even at the cellular level, making some repairs at the cellular level, eventually helping neurons connect with what they should be connecting one to another, changing growth cones, or how neurons grow and connect with different parts of the brain. That's more advanced tech, but it's within the radars.
Yeah, there's a question with these sorts of things, in my mind, whether these are likely to come before or after you get human-level AGI. Because if you did have a human-level AGI with its ability to have sensors and actuators at the nanoscale, exactly, you would figure it would be able to figure that out better than humans can, where our minds are just not well designed to operate at that scale. But I mean, the relative speed of advance of different technologies has been a hard thing for anyone to estimate.
Yes, and your observations about the importance of considering the speed of advancement in other technological fields give rise to another question, and that is, what advances in other fields are necessary for the technologies that you are working on to become implemented within the broader world?
Well, I think the biggest bottleneck we have right now in applying AI to cure aging is more social, cultural, and economic than technological. It's really just the siloing off of data. Like I've often thought, if the anonymous hacker collective hacked into every pharmaceutical company's databases and just opened up all data about every subsystem of the human body, this will be a major contribution to the human species, right? So just the fact that we can't get all data that's ever been collected relevant to human health, pull it together in one giant knowledge graph and stir and apply it to an AI is pretty fucking pathetic, right? Because, I mean, humanity is getting old and dying, and we're not really doing our best. Because, why? Because people want to sit on the data they've collected so that they can, distribute more money to the private equity firm that owns shares in the VC firm that funded that company or something, right? That's kind of absurd, and that, in a way, may be the largest obstacle, because we don't know what would happen if we could actually take all the world's data and put it into our best machine learning and reasoning algorithms right now. I mean, I would say there's certainly there are other issues. I mean, I'm among many other projects, I'm working with a company called Simuli on an AGI chip, where we're looking at putting symbolic reasoning and different types of AI beyond deep learning at the hardware level. So I mean, having better AI hardware would help. Certainly, in terms of data, even though data siloing is a problem, we also have an issue that there's been very little time series data about the temporal evolution of different subsystems in the human body at different scales gathered. And without that time series data, you can't really learn dynamical models of what's happening inside the body. Without those dynamical models, you can't make say, a good simulation of the human body that you can use to bypass a bunch of the clinical trials that we're doing, right? So there's been a lack of interest in gathering time series data, which is rooted in a lack of interest in systems biology, which again is quite perplexing, because the ancient Chinese recognized that the body is a holistic dynamical system, yet modern medicine hasn't woken up to that yet, partly because that's harder to monetize according to the ways that the FDA allows you to monetize things. So again, it comes back to sort of social, cultural, and economic factors pervading even into the decision of what type of data to gather. So there's a lot of obstacles there, but what's frustrating is so many of them come down to the stupid ways and counterproductive ways that human society organizes its various sorts of resources rather than to fundamental technological obstacles.
So if someone were to develop a sci-hub for medical data, that would help your endeavors.
Not that I want to suggest that to anyone.
Disclaimer. I would say that Ben is completely right. Scientists around the world create knowledge, publish on the journals, and then they're not open source. Right? We review, we create the content, and they're not open source. That's one of the reasons why, for example, we publish our papers on Frontiers of Neuroscience. It's an open source journal. Everybody can have access to it. So we're all collectively building this amazing content, knowledge that should be available to everyone around the world to create a better world. So I think Ben is really talking about something crucial for our future.
Yes, indeed. Thank you. And Jean, any thoughts?
Sort of, bridging those, but publishing and sharing results is really important. But the process of science is one of, open critique of one another's work. That's really important. A lot of you guys have the activist badge. I would encourage you to be active in educating yourself about these different longevity approaches, and reach out to the harshest critics of these approaches and learn from them. And if possible, get them together with the proponents of these approaches and have real scientific debates about what's going to work, what are the big challenges that we need to overcome to make them work. There's a lot of, I think a lot can be accomplished that way and more progress can be made.
Yes, thank you very much. Discussion, discourse, vigorous debate,
yeah.
Advocacy, activism are all essential, and I think these are key takeaways from this RADFest. I'm curious, Jean, along the lines of vigorous discussion, our friend John McPherson wonders, could nanotech rebuilding of brain tissues be better than using surgery to do it? What do you think about the prospects of that?
I don't know.
Go ahead first.
Okay. Well, we already, to some extent, know how to build a brain. Like, we don't need to know, because if we use fetal tissue, that does it on its own. So I think we're much closer to implementing that, which is why I favor that now. But in the future...
There you go. Thanks. Thank you so much. Love you too. No, it's true. It's complementary. These are the first approach for curing and repairing the brain at that scale. But for example, if you want to create a new memory that you lost, that was stored on that specific part, you need the more advanced nanotech. So they're complementary. First, you use the biotech approach, as Goertzel mentions it. But that biotech approach on its own works, right? You put the small graft there on the brain, and it reattaches and reconnects. But you don't have control over what connections are being established. That's where nanotech comes in. Where nanotech comes in and is able to say, okay, this is what we have. Not just nanotech, but AGI. You cannot control a large number of nanotechnological devices without artificial intelligence. And going back to our first question, AGI is, for example, a fundamental tech for the future of nanotech. So they're building on one another. So first would be, John's technology. Later down the road, nanotech helping fine-tune the details of the therapy.
Yes. Thank you very much, Jean. And Nuno, I think we can fit in one more question from our friend David Bowden, who wonders, why do you think some people, even some people in this audience, are uncomfortable with the idea of a mind-machine interface? It seems completely necessary to our friend, given the rapid proliferation of human knowledge and the increasing pace of our society, as well as being a tool to perhaps enable us to lead happier lives. So what are your thoughts on the sources of this discomfort?
Yeah, the discomfort is reasonable. One of the fundamental decisions as a society that we have to do, and this happens in every new technology. Let's start with fire. When we created fire, fire could be used to cook or burn a forest. So we need the policies, the legal systems, and the requirements to evaluate what's the proper use of the technology and the threats for society. That's not just for fire, for a knife, right? You can use it to cut your food or kill somebody. A weapon, same thing, right? Nanotech, same thing. Brain-computer interface, exactly the same challenges. So it's fundamental that, as John mentioned, that as a society, we welcome the criticists, understand their concerns, and together we predict the eventual challenges that we're going to face. Think about Facebook. If we had the right policies in place, we would not be facing the challenges that we had to face later down the road when things were not the way we wanted them to be. I mean, so all the work we do before help us prevent future problems. I think it's fundamental.
I mean, if you look at a very fundamental philosophical level, right? I mean, every open-ended intelligent system in the real world as it evolves is doing two things. It's individuating, it's maintaining its boundaries as an organism, and then there's evolution, which is a force of self-transcendence. It's trying to grow beyond itself. And these two desires, of course, contradict each other, which is what's interesting and what drives growth. And what you see here with things like brain implants or genetic engineering or any of these things, I mean, these clearly are forces for self-transcendence. They can help you grow beyond what you are, but people are afraid that they break individuation. They're afraid they're no longer going to be themselves. And what's happening is we're being pushed by technology to reconceptualize what is ourself, right? I mean, if you look in pre-civilized peoples, they conceptualize their self as part and parcel of the land that they lived on, and they don't know what to do if they fly to a different part of the world, right? And now we don't do that anymore, right? Like we fly all over the place. And I mean, I think in a similar way, we will come to conceptualize ourselves as not being that tied to the specific wetware that we grew up with. But it's, as Nuno says, it's quite natural that this takes some psychological adaptation for people. And in the historical sense, I would say people are adapting way faster than they have ever in human history, right? But still people's minds are not adapting as fast as the technology is growing, which is making things interesting, and is why there's merely like hundreds to thousands of people huddling in a room now talking about these technologies, rather than it being something that's, you know, on the tip of the tongue of every single person on the planet, which would seem to make more logical sense once you really embrace these technologies.
And yet, the minds of our esteemed attendees today are at the forefront of the kind of adaptation you described. So thank you very much, Ben. I wish we had centuries more to delve into these kinds of questions.
We do, actually, longer than that. So we have,
Indeed.
Millennia and millennia and to infinity and beyond.
So shall we continue this conversation at RADFest 2022?